They say the worst sound in history wasn't the explosion itself. It was the collective, gasping intake of breath across a continent, a silence that followed the primal, impossible shriek of metal and superheated steam. A silence that meant the veil had been torn. When we think of a tragedy like Chernobyl, we instinctively search for the spectacular villain. We picture the arrogant scientist, the monumental structural flaw, the failure of concrete or steel. We imagine a vast, complicated industrial mechanism breaking down. But what if the root of the world's most devastating nuclear disaster was far quieter, far more mundane? What if the engine of global catastrophe was simply a piece of paper? A single poorly written instruction, a single life-erasing typo, hidden deep within a bureaucratic document. This is a story about the night of April 26, 1986. But it is not a story about atoms. It is a story about the unbearable weight of human exhaustion and the devastating power of an omitted comma. We must first understand the stage. Chernobyl was not just a power plant, it was a symbol. A towering, brutalist monument to Soviet industrial ambition. Its heart was the RBMK reactor, a magnificent engine of power, but also a beast with a dark... This reactor, unlike most Western designs, was notoriously unstable at low power. It was a coiled spring. Push it too low, and it would not gracefully shut down. It would snarl. The engineers knew this. The design was complex, and its instability was managed not by solving the physics, but by creating layers upon layers of strict, almost religious, procedure. In the Soviet culture of the 1980s, speed was virtue, and questioning procedure was treason. The rule book was gospel, and the men who ran the station were disciples. Now fast forward to a Friday night, April 25th. The control room of reactor number 4, a cavern of blinking lights and dial gauges, humming with a barely contained energy. On the schedule was a seemingly routine safety test, a check on the turbine's inertia, nothing more. A necessary but tedious bureaucratic hoop jump. The shift started late. Delays from the local power grid pushed the start of the test past midnight, ushering in a tired, less experienced crew. Crucially, the chief engineer overseeing the test was not a nuclear specialist, but an electrical one. The entire atmosphere was saturated with haste, ambition, and fatigue. Imagine a man alone in that control room, his eyes gritty from the late hour, staring at a sheet of paper that contained the fate of a continent. This paper, the test protocol, was his guide. On one page, a single, absolute instruction existed. The reactor's thermal output must be stabilized above 700 megawatts. That was the line in the sand. Below it, the coiled spring would become dangerously volatile. Above it, the system would remain predictable. But as the operators began the controlled power descent, something disastrous happened. A misunderstanding, a miscommunication, a failure of clarity that experts later identified as the single infinitesimal crack that brought down the entire structure. The operators, attempting to stabilize the reactor at the 700 megawatt mark, made a mistake with the automatic control system. A crucial regulator rod was accidentally inserted too deeply. The power plummeted, not to 700 megawatts, but to 30 megawatts, 100 times lower than the safety limit. The single devastating typo was the failure of the written procedure to forbid this with absolute catastrophic clarity. Some investigations point to a section of the procedure that was ambiguous about when the manual control rods should be reinserted. Others suggest the fatal ambiguity lay in the exact number, a misplaced decimal point in a hastily translated safety manual that confused the power output units. Whatever the specific articulation, the core problem was that the protocol failed to account for this precise moment of operator exhaustion and error. It failed to say, if you pass this threshold, stop. Walk away, end the test. It allowed for a moment of human panic to override absolute physics.
The men in the control room were now trapped. Their goal was to bring the power up to resume the test. The clock was ticking. They began to manually withdraw the control rods, the literal safety fuses of the reactor, in a desperate attempt to restore power and save the test. But the reactor, operating in this super-low, unstable state, had begun to poison itself. A buildup of xenon-135, an invisible neutron absorber, was choking the reaction. The core was turning itself into a poisoned lung. The operators were pulling out the rods, but the power refused to climb predictably. They were, without knowing it, loading a grenade. At 1:23 a.m., the test was deemed ready to begin. They had only a few moments before the xenon poisoned the core entirely, and they desperately wanted to get the data they needed. They hit the buttons. The final agonizing twist of human error was the emergency stop. When the lead operator, realizing too late the catastrophic instability, slammed the AZ-5 button, the big, red emergency shutdown, he thought he was saving them. But the flawed design of the RBMK, combined with the extreme heat, turned the safety feature into a weapon. As the control rods dropped, their tips were made of graphite, which actually accelerates the nuclear reaction for a few critical seconds before the absorbing material enters the core. In a stable reactor, this is negligible. In a poisoned, unstable one, it was the final match to the fuse. What followed was not a neat chain reaction, but a chaotic, explosive thermal release. The water flashed to steam, and the 1,000-ton lid of the reactor was thrown into the pre-dawn sky. The tragedy of Chernobyl is not a clean, clinical story of physics. It is a deeply, terrifyingly human story. It is the story of a culture that prioritized a written target over human instinct. It is a testament to the immense, cascading power of small things, an ambiguity in a single sentence, a tired eye misinterpreting a number, a single, devastating typo in the grand operating manual of our world. It reminds us that the most powerful, most complex systems we build, from nuclear reactors to global financial networks, are always, forever, only as steady as the most exhausted, most fallible human being who signed the last document. And it forces us to ask, in the vast, humming infrastructure that governs our modern lives, how many other devastating typos are lying hidden in the code, the procedure, and the protocol, simply waiting for the wrong time and the wrong tired hand to finally reveal their true, terrifying power?